Imagine waking up tomorrow and the internet is simply gone. No Google, no YouTube, no WhatsApp, no Instagram, no online banking, no streaming, no cloud storage. Billions of people would suddenly lose access to the digital world they depend on every day. But here's the strange part. You probably use the internet every few minutes, and yet most people have no idea what the internet actually is. Is it satellites? Is it Wi-Fi? Is it the giant data centers operated by technology companies? Or is there something much bigger hiding underneath? Today, we're going underground, underwater, and across continents to discover how the internet really works. And by the end, you'll understand what happens in the few seconds between tapping a YouTube video and seeing it appear on your screen. Let's start with one of the biggest misunderstandings. The internet is not the cloud. The cloud is simply a convenient name for computers that exist somewhere else. When you upload a photo, send a message, or watch a video, that information doesn't disappear into some mysterious digital space. It travels through real machines, real cables, real buildings, real electrical systems, and enormous networks of computers. At its simplest level, the internet is a global network of networks. Your phone connects to your Wi-Fi router. Your router connects to your internet service provider. Your provider connects to larger networks. Those networks connect to other networks until your request reaches the computer you're trying to communicate with. And this happens incredibly fast. But how does your device know where to send the information? That's where one of the internet's most important systems comes in. Imagine trying to deliver a letter without an address. You could have the perfect message, but the postal system wouldn't know where to take it. The internet has the same problem. Every device communicating across a network needs an address. These are called IP addresses. IP stands for Internet Protocol. An IP address helps identify where digital information should go. But humans aren't very good at remembering long strings of numbers. That's why we use names. For example, instead of typing a complicated numerical address to reach a website, you can simply type its domain name, like youtube.com. But your computer doesn't really think in website names. It needs an IP address. So when you enter a website address, your device asks another system, "Where is this website?" That system is called DNS, the domain name system. Think of DNS as the internet's giant phone book. You type a name, DNS finds the corresponding address, and your device knows where to go. But finding the destination is only the beginning. Now the data has to travel there. Here's something fascinating. When you send a message or request a video, the information usually doesn't travel as one giant block. It is broken into smaller pieces called packets. Imagine sending a huge book through the postal system. Instead of sending the entire book in one massive package, you could divide it into hundreds of smaller packages. Each package could travel through the network. Some might take different routes. Eventually, they reach the destination, where they are put back together. Internet packets work in a similar way. Your request is broken into packets. Routers examine those packets and decide where they should go next. And here's the amazing part. There isn't one single road connecting the entire internet. There are millions of possible paths. If one route becomes congested or unavailable, data can potentially take another route. This enormous interconnected structure is one reason the internet is so powerful. But what are those digital roads actually made of? You might imagine that most internet traffic travels through satellites, but that's not the main story. A huge amount of the world's international internet traffic travels through something much more ordinary: fiber-optic cables. And many of these cables lie on the ocean floor. Thousands of kilometers of cable connect continents beneath the world's oceans. Inside these cables are extremely thin strands of glass. And instead of sending information as electrical signals over long distances, fiber optics can transmit data using pulses of light. Think about that. When you watch a video from a server on another continent, the information may travel thousands of kilometers as light moving through glass. These cables connect major regions of the world. They reach coastal landing stations, then connect to massive terrestrial networks, and eventually to data centers and internet providers. So the next time you watch a video uploaded from another country, remember, your data may have crossed an ocean to reach you. But where does that video actually live? Usually somewhere inside a data center. Imagine walking into a giant building. Rows upon rows of machines stretch into the distance. Fans roar constantly. Cooling systems work around the clock. Power systems are designed to keep everything running. These are data centers. They contain enormous numbers of servers. A server is essentially a powerful computer designed to provide information or services to other computers. When you watch a video online, the video may be stored across servers in one or more data centers. When you click play, your device sends a request. The network finds an appropriate server. The server sends the requested data back, and your phone or computer begins receiving it. But there's another trick that makes this process much faster. It's called caching. Instead of always retrieving information from one distant location, popular content can be stored closer to users. This means someone in one country doesn't necessarily have to retrieve every byte of a video from a server thousands of kilometers away. The content can be distributed across many locations. This is one reason modern websites can load so quickly. Here's another common misunderstanding. Wi-Fi is not the internet. Wi-Fi is simply a method of connecting your device to a local network without using a physical cable. Your phone communicates with your Wi-Fi router using radio waves. But your router still needs a connection to the wider internet. That connection might come through fiber-optic cable, copper lines, a cellular network, or another technology. So when you sit on your couch and watch a video over Wi-Fi, your data might take a journey like this: phone to Wi-Fi router to your internet provider, through larger networks, across fiber-optic cables to a data center, and then all the way back. All of this can happen in seconds, sometimes much less. Now let's look at one of the internet's greatest secrets. How do millions of independent networks know where to send traffic? The answer involves routing. Large networks exchange information about which destinations they can reach. One of the key technologies involved is called BGP, the Border Gateway Protocol. Think of BGP as a system that helps networks decide. If you want to reach this destination, send the traffic this way. It doesn't create one perfect map of the internet. Instead, networks constantly exchange routing information. This allows traffic to move between different organizations and networks across the planet. And because the internet is decentralized, there is no single computer sitting somewhere controlling the entire internet. There is no giant internet machine. Instead, countless networks cooperate and communicate. That's one of the fundamental ideas behind the internet. Let's put everything together. Imagine you open your browser and type a website address. First, your device needs to discover where that website is. DNS helps translate the human-readable domain name into an IP address. Your device then sends packets toward that destination. Routers along the way decide where those packets should go. The packets may travel through your local network, your internet provider, larger backbone networks, and possibly underwater fiber-optic cables. Eventually, they reach a server. The server processes your request. It sends information back. That information travels through the network again until it reaches your device. Your browser receives the packets, puts the information together, and displays the web page. All of that can happen while you're still thinking about what you want to click next. The internet feels invisible, but it isn't. Behind every search, every video, every message, and every website is a physical world of cables, routers, antennas, servers, data centers, power systems, and millions of interconnected networks. The internet isn't a cloud floating above us. It's a planetary infrastructure built by humans and connected almost everywhere. And perhaps the most incredible part isn't that billions of devices can communicate. It's that they can do it in fractions of a second. So the next time you tap a screen and information instantly appears, remember what's really happening. You aren't simply connecting to a website. You're connecting to a global machine that spans continents, crosses oceans, and operates almost invisibly around you. This is the Internet, and now you know how it works.